Okay, Scott, we're going to take a little quick look at your ass kicker. It's a no name. It's a 1x2. Scott wants me to set this thing up for comp. He says he's going to try and run on 20 volts. I said he's crazy. He says I'm going to do it anyhow. I said, yeah, okay. Long story short, I don't feel that that's right. 20 volts. I mean, it's okay for a short little key, but not a long period of key. The other thing I suggested is that he, if he's going to do a true comp box, we get rid of the relay, so it's straight in, straight out. He says no, he wants to keep his relay bypass in line. I said that's fine, but obviously needs new power wires. We're going to change a bunch of other little things. Most of them are electrically oriented, like trying to get the most amperage to each circuit. Like we're going to change this wire out. This is an older built box, so to see the independent transistor feeding system that everybody dogs on actually being employed in this thing from back when in the day says something. Might be onto something there, but we're going to modify the transformer. We're going to pull this out, put a different one in there. We're going to change the power distribution network here, and then we're going to change out the value of this cap because that's not a high enough kV. If he stands on it for too hard, too long, that cap will end up toasting on him. So then the other thing is we got to get rid of this voltage divider that's here on the input. This is not a pad because it doesn't couple to grounds, therefore it acts as a voltage divider. We're going to change his input tune so it's appropriate and reads right when it's low versus hiding it behind these resistors. We're going to change it so that he doesn't have a resistor here to attenuate the output power of this 2870 or this 2290. And it'll probably help him hop up a little bit. The primary reason that he sent it in to me though is he smoked this resistor. If we get down in here, you can see that this 10 ohm resistor is burnt up. So we're going to replace the 10 ohms on both sides. We're going to have to pull both pills, and I've got to make sure that their beta gain the same. So I've got to find a transistor. This one's dead. I got to find one that's going to match this one electrically. So we'll get that squared away. Probably change out his flyback buffer resistors here, and change out his disc capacitors also. So we're going to change just a couple small things in this thing, and it's going to make a big difference. Anyhow, Scott, here you go. Get her done. First thing I'm going to do is clean it because it's dirty. As you can see, it's got shmoo on everything, but that happens. It just happens. Board's not corroded, so that means it's going to clean up just like new. So off we go. Scott, let me show you something. This is the remnants of your ground lead that come out of your box. Okay. Now the reason I so strongly suggested that we replace the power wires that go in and out of the amp is this right here. If you can look real close, you can see the gauge of wire. The insulation is the same, but the number of strands and the size of the wire is almost double. And it goes the same for this aluminized wire that was in there. I don't know who put this in. This is really cheap shit. But we replaced it and gave it a little bit longer leads than 1 inch off the back of the box. Oh yeah, we're going to volt this little guy. So Scott says to me, fix as needed. I run it at 20 volts in competition. That's what he says to me. So I said to him, I said, well, how far can I go with it? And he goes, do your thing. I said, okie doke. So Scott, one of the very first things we went in is we took the transformer off. We changed out this transistor. Now, this is the transistor that came out. I'm going to send it back with the amplifier. It is lot IJ. Now, I had to pull this transistor out and gain check it, and it had a gain of 41. So I was able to find this transistor, which is also an IJ, had a gain of 43, which is close enough. I mean, everything else was either 35 or was way higher than this or way lower. This is pretty close, within 2 beta gain of each other. Since I've already keyed it, they're now the same gain. And what you're trying to do is you want to keep the gains of the transistors really close to each other because they pair up and they'll pull one transistor down. So if this thing's got a high gain, and then I put like a gain of like 5 in here, let's say, I try to avoid anything below 9 because beta gains below 9, it's just a matter of time. You've reached the beta gain floor and it's going to start corroding the inside of the transistor and it's going to cause breakdown. Anywho, until this transistor quits, it's going to fight with its pair transistor because remember, we're pushing and pulling. So one side's turning off and the other side's turning on. The other side's turning off, the other side's turning on, and we're doing as it rectifies the top side of the envelope you got on, and then on the bottom side you got off, from the negative voltage peak to the positive voltage peak, so it's cutting on and off. This is going doot, 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 push-pull. Well, if the gain, the beta gain slopes aren't the same on the transistors, they'll fight each other a little bit until they pull the gain down of the higher transistor, and in turn the lower gain component will also drop in beta gain. So what can happen is if you put a beta gain of 5 in here, it'll run for a New York second, but meanwhile it's going to be killing this other pill until it gets down to this transistor's gain, and that being so low of a gain, it'll end up eventually killing both pills. It'll pull this one down to almost nothing, and if this one doesn't quit before it gets this one all the way down to the floor, it's going to pull the gains way down. So anyhow, we put a match transistor in there in beta gain and slapped it in there. I replaced your flyback resistors. We changed out your transformer. Now, this changing from this transformer to this transformer does not help it do any more wattage. You can make this transformer resonate and perform the same way as you can this transformer and this transformer and this transformer by changing just a couple things, either it be the turns or the capacitance across the top of the transformer. When you say competition to me, I think heat, right? So a transformer that sits all the way down on the deck of the amp like that doesn't get any airflow around the bottom side of the cores. Heat is bad. Well, mine's elevated and allows for airflow across the bottom of it. And the other thing is it allows for independent pill distribution. Well, we've seen that here with this wire that was going through that toroid. I like a little bit heavier gauge wire because I know that each one of these transistors pulls about 25 amps a piece, 24 amps a piece, full boat. Now remember, there's only one of them on at a time. Now there's a small little crossover window where they're both either turning on or turning off, but they're not at a full amp load. Okay, so we know for a fact that we're going to see about 30 amps worth of draw. Well, yeah, in theory that can handle 30 amps more efficiently over a short distance, not a long distance. So we upped the gauge of wire. The other thing is we took the little piece of 22 gauge that went from here over to here and fed the one pill section. Clean that all up for you. I changed the capacitor on the output of the one pill section. They had two 1000 puff capacitors in series to get you 500, which it needs a 620 or a 680 with some other factors. We took the buffer resistor out. We replaced your 10 ohm resistor. We changed your input tune quite a bit. We took out the voltage divider circuit that was in front of it. And like I said, we removed the little resistor here. Oh, the other thing is, the grommet that was in here wasn't even big enough for the hole. I noticed I picked the power wires up and the grommet popped out the bag. So we went ahead and put a new grommet in here so it's actually technically safe. But the biggest thing that you're going to see in performance is going to be the gauge of wire, because now it's not drinking through a little tiny straw, it's drinking through a hose. Okay. Amp is on. Let's go over here and talk for a minute. Look, I could use the bench supply, but that's set at about 14.5. This guy likes to operate at 20 volts. I bet you he charges at 20 and runs at like 17, 18 volts. We're going to go to 17.5 today, and we're going to see what this thing does. It's going to do approximately 300 bird and about 700 peak watts. And that's by being driven by just a mainstream, very detuned Cobra RCI 2950, which only does about 20 peak watts. Now Scott has got himself a competition radio. He told me it does about 30 watts. He sets the dead key at about 2 watts and just lets it swing, 30 peak watts. And we're talking peak power, you guys, not talking bird. Calm down. So we're lucky if we can get a radio that does bird power with the current MOSFET technology that everybody's sticking in it, like maybe 12 to 18 bird. But you guys all know that the bird power is actually a derivative of how much audio is inserted into the carrier, thus driving the average wattage, because what would be the point of a unit measure if it was... Sorry, my brain gets numb when I listen to some of these guys talk, especially on Facebook, where they're talking like they know... just hurts my mind. Anywho, I needed a variable voltage power supply that could handle the deal. This is a 100 amp RSP 1515. So there's 100 amps, one power supply. We've all seen me use these before. So let's get this sucker plugged in and let's see what we get going on for power here. Whoop. Okay. Now hold on. Plugging this in down here is going to be a mistake. Around. There we go. Let's go over here. We're going to plug into the source. However, slightly over-taxed on-pin outlet. Okay, 14.5. That's where we're at. I'm going to need my voltage adjustment device. And let's put the amp off, and we'll show everybody baseline. So we're in the 1,000 watt position. That's in PEP, that's an average. It's 5 watt slug back in the bird, 10,000 watt dummy load. 5 watt slug in reverse, between the 2950, and of course, the 1x2. Ah, 7/8 bird. Now the reason I went through the big speech about undertuned radios and bird average powers, results may vary. If you have a different radio that does more bird wattage, you're going to see more bird power. If you have a radio that does less bird wattage, you're going to see less bird power. If you have a radio that produces more peak power, you're going to see more peak power. Just saying. That's why I'm trying to shoot for right down the middle, mainstream, just very moderately tuned radio, doing about 30 watts. About 7/8 bird. Okay. Let's get that out of the way. The reason I'm going off on this is there was this huge big running debate on Facebook about this. And I was sitting there literally taking my head, beating against the table going, oh my God. Come on guys, let's get a little bit more knowledge and it all makes sense to you. So I figured I'd share a little bit. All right. Here's our input tune. This is the variable all the way open, Scott. Nice and low coming back to the radio. Here's our output power. About 600 watts. About 180 bird. It's on 14 volts. Come on. Come on, screwdriver. So we'll go to 15.5, 15.5, close enough for the girls I dance with. 1 whole volt increase. So we picked up about 30 watts on the peak envelope side. And about 20 bird. Let's go on up to 17. 17.69. It's about 225 displayed. And about 650. Almost 700. Peak. Man, I can't get the pitch just right. They can put out more average, I guarantee it can. Mainstream, low-end mud duck, power radio amplifier. Yeah. Look, Scott, this thing's set. Doing 700 peak on 17 volts. And I mean, the voltage ain't moving. Ain't moving. It's good stuff. It's tuned up, dude. Scott, I appreciate you sending this thing up to me. I'm sorry I had it for so long. Honestly, got set on the shelf in the box and totally forgot about it. He called me today. He says, man, you going to work on my box? I went, oh, shit. I've had this for a couple months, you guys, and I feel horrible about it. So I thought I'd give him get it rushed through here and get her done. Well, off to Facebook and now do a live feed of that. I got stuff over there I got to go work on. The Facebook side of business, that is. Anywho, gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. Come find me on Facebook, Twitter, Snapchat, Instagram, and of course right here on the YouTuber. Click the subscribe button right down there, down there off the edge of the screen. We can come play along with the castaways. Gentlemen, appreciate your all support. Scott, appreciate you, buddy. Last kicker is turned up straight, right, ready to go. Brand new transistor, beta gain matched. And, yeah. Let's see here. What do we got going on here? Scott, give me a call if you want me to hook this up so you can have an external key switch. Because I will gladly take a wire and go from here to there and get it all squared away. So you have a switch here, click, locks the relay out for the shootout. Because you don't want to be relying on the transistor key-in circuit, the auto key-in circuit at the shootout. Anyway, let me know what you want to do, man. I will get with you. Gentlemen, peace. I'm out. I'll see you. Bye.